Hey, welcome to Enhanced Smart Skills. In the book Telecom Testing Simplified, one of the trickiest things it talks about is the good old shared office network. It sounds simple, right? But for us as software testers, this is exactly where some of the sneakiest bugs love to hide. So today, we're going to tear that network apart, figuratively, of course, and simplify the key ideas from the book so you know exactly how to test it like a pro. So we're going to break this all down into 5 easy steps. First, we'll look at the problem itself. Then, we'll get into the digital building blocks you need to know. After that, we'll see how to actually teach the router and organize the switch. And we'll wrap it all up with a super practical checklist made just for testers. Let's dive in. All right, so picture this. You've got a company that's absolutely booming. The sales team is growing, the engineering team is growing, and everybody is just plugging their computers into the same network. Now, that might seem easy and efficient at first, but trust me, it very quickly turns into a huge headache for security and for performance. And that right there brings us to the central problem we're going to solve. How in the world do you take one single physical network, one set of wires, one box, and magically create 2 or even more completely separate and secure digital spaces? That's the puzzle for today. Okay, let's get into the specifics because this is where it really matters. Your sales team, right? They need rock-solid access to their CRM and perfect, smooth quality for their video calls with clients. Meanwhile, your engineering team needs to get into secure code repositories and, really importantly, restricted production servers. Plus, they're slinging massive files back and forth all day. So just throwing them all onto one big open network, it's not just messy, it's a huge security risk. I mean, you never want someone's sales laptop to even have a sniff of a path to a production database. No way. So to solve this puzzle, network engineers use a handful of core technologies. And look, the names might sound a little scary, a little technical, but the actual ideas are super simple if we just think about it like we're building an office building. That's what we're going to do. We're going to build a digital office building to keep everyone safe and sound in their own space. Okay, our very first building block is something called a VLAN. That stands for Virtual Local Area Network. Now, the official definition says it's a way to create logically separate networks on a single physical switch. But what on earth does that actually mean for you and me? Well, this is the perfect way to think about it. A VLAN is nothing more than a secure, separate floor in our office building. We're going to put the sales team on, say, VLAN 10, that's our 10th floor, and we'll put engineering on VLAN 20, our 20th floor. The cool part is, even though they're all plugged into the very same box, their network traffic is now totally isolated from each other. It's just like being on different floors of a real building. All right, next up we have DHCP. It stands for Dynamic Host Configuration Protocol. And its whole job in life is to automatically hand out a unique address, an IP address, to every single device that plugs in. So in our office building analogy, DHCP is like the super helpful receptionist in the lobby. When a new salesperson shows up and plugs their laptop into a jack on the 10th floor, our receptionist, DHCP, instantly gives them an office number or an IP address that belongs to the 10th floor. And it all happens automatically, in a split second. They don't have to do a thing. That automation is absolutely key. Okay, our last digital building block for today is NAT, which stands for Network Address Translation. You can think of this one as the main gatekeeper between our private little office network and the huge public internet out there. In our building, NAT is the mailroom. Simple as that. It takes all the mail, all the internet requests from every single person on every single floor, bundles it all up, and sends it out using the building's one single street address. So to the rest of the world, it just looks like all that traffic is coming from one place, our building. All right, so we've got our building blocks, VLANs for the floors, DHCP for the receptionist, and NAT for the mailroom. Now it's time to actually build this thing. We're going to start with the router, which is basically the brain of this whole operation. We need to teach that router all the rules for our new digital office. Really, it all boils down to 4 main steps. Step 1, pretty obvious, we connect the router to the internet. Second, we create these virtual doors for each of our VLANs, so the router knows how to talk to the 10th floor and the 20th floor. Third, we set up our friendly receptionist, DHCP, and tell it what addresses to hand out for each floor. And last but not least, we give our mailroom, NAT, its marching orders for handling all the outgoing internet traffic. Now look at this command. You do not need to memorize this, but as a tester, it's so powerful to understand what it's doing. This one line of code is basically the master instruction for our mailroom. It's telling the router, hey,
take any approved traffic from inside our building and send it out to the internet using our one main public address. The main thing to get here is that this one little rule is what gives everyone internet access, no matter what floor they're on. Okay, so if the router is the brain, then the switch, well, the switch is the physical building. It's the hardware. It's that box with all the little ports where people actually plug in their laptops. So now we have to tell this physical box about the virtual floors we just designed.
Setting up the switch is a pretty simple three-step deal. First, we set up a special port called a trunk port. Just think of this as the building's main elevator. It's the one special connection that can carry traffic from all the floors up to the router. Next, we actually create our floors in the switch's memory, VLAN 10 and VLAN 20. And finally, we go through and assign each physical port to a specific floor. So, ports 1 through 10 are for sales, and ports 11 through 20 are for engineering.
And the magic command here? It's this one, switch port mode trunk. This is the line that turns a regular, boring port into that super-powered elevator we talked about. It's telling the switch, hey, this one port that connects to the router, it's not for just one team. It has to be able to handle traffic for every single floor in our building. Okay, the network engineers did their thing. The configuration is done. They say it's all ready to go. But now comes the most important part, at least for us, verification. How do we actually prove that this whole thing works the way everyone thinks it does? So let's put on our tester hats for a second. The system's built. What's the very first thing you would check? What are the absolute must-do tests here to make sure it's working and that it's secure? All right, first up, let's do the happy path test. We take a laptop, we plug it into a port we designated for sales. Does it get a 10th floor IP address? Yep, it does. Okay, now we grab another laptop, plug it into an engineering port. Does it get a 20th floor address? Yes, it does. And can both of them get out to the internet? Check, they can. So that tells us our basic setup is working. Phew. Okay, let's turn this into a real practical checklist you can actually use. First checkbox. Does the device get an IP address from the right floor? We just confirmed that. Check. Second, can it get to the internet? Yep. Check. Third, and listen up because this is the big one for security. Can the sales laptop see or ping or access anything that's supposed to be only on the engineering floor? This test has to fail. If that sales laptop can see an engineering server, you've just found a major security hole. And finally, don't forget the non-functional stuff. How's the video call quality for the sales team? Is it still crystal clear? You see, great testers always look beyond just, does it connect? And that right there is the biggest takeaway. When you really get the why behind the network's design, you stop writing simple pass-fail tests. Instead, you start designing these really smart, insightful tests that find the exact kinds of security flaws or performance problems that even the engineers who built it might have missed. So that leaves me with one last question for you to chew on. What other invisible infrastructure, just like this network setup, could be quietly impacting the system you're testing right now, every single day? Because thinking about these hidden layers, that's what takes your testing skills to the next level. It's what makes you truly invaluable to your team. I really hope breaking down this office network makes you feel a lot more confident tackling these kinds of telecom concepts. If you found this video helpful, do not forget to like the video and subscribe to enhance smart skills for more simplified telecom and testing concepts.